Our next topic on the menu is piecewise defined functions. So what are the piecewise defined functions? Well, sometimes we come across a function that requires more than one formula in order to obtain the given output. And so such a function is called a piecewise defined. So for example, this graph, this function is composed of two pieces that behave differently. So from 0 to 10 on x, this is a line with a slope. What is the slope of this line? Basically, it's 50 over 10, so that's 5, right? So this, the equation of this piece would be y equals 5x plus 0. But again, it's not the entire line, it's just this piece from here, for x's from 0 to 10. Okay, so let's start here. So here, it's 5x, y equals 4x's from 0 to 10. Now, beyond this point, it becomes just a constant line. And this line has a different equation. This is actually y equals 50. That's the equation of that line, right? And it goes on indefinitely. So after this, when x is actually greater or equal to 10, we have x equals 50. Okay, and then we write y equals, we write two separate equations, two separate descriptions for different domains. This is what a definition of a piecewise defined function looks like. If there is more than just two pieces, sometimes there could be 3 or 4 more, you would just continue describing those graphs and the domains on which those graphs work. So here's another example of a piecewise defined function. This is an absolute value function, right? We can actually write it in just one formula as f of x equals absolute value of x. But if we wanted to explain how to graph this function, so when x is positive, so when x is greater or equal to 0, then your f of x just equals x, right? So for example, f of 5 is absolute value of 5, so it's just 5. F of 3 is absolute value of 3, so it's just 3. So your input value equals your output value. Input value equals your output value. So when x is positive, then f of x is just x, equals x, right? But what if x is negative? So x is less than 0. What happens then? So for example, f of -1 is absolute value of -1 is just a positive 1. So f of -2, absolute value of -2 is positive 2. So input is -1, output is positive 1. Input is -2, output 2. So it's actually the opposite. Your output is the opposite of the input. So that's a negative x, the opposite of x, for when x is less than 0 or negative. So this is how you define a absolute value function. What does the graph look like? So basically, what happens is that our domain is divided into two pieces. X is less than 0 and x is greater or equal to 0. So we're going to start, let's start with this piece right here, and that's this side of the x-axis, right? It's the right side after 0. And this is basically called an identity function. So y equals x. So same, y has the same value as x. So if x is 2, then the y is 2. If x is 4, then the y is 4, and so forth. So, but it only works up until we from x equals 0 and up. So on this side. Now on the other side, it's actually okay. So on the other side, where x is negative, it's the opposite. The f of x is the opposite of x. So when x is negative 2, y is 2. X is negative 4, y is 4. And hence our graph looks like this. Okay, so this is the graph of the absolute value function. It is a piecewise defined because it's composed of two different lines.